For thousands of years, humans have stared out into space, marvelled at the stars and wondered what else might be out there. Humans have also always made up stories about space, from the constellation stories of the Greeks to modern day blockbusters such as Star Wars, and humans are fascinated about what we might find. Now, with NASA and private companies like SpaceX pushing forward our understanding, here are 10 things you should know about space. 1. Our universe came from nothing. Before the Big Bang, there was nothing. It can be quite difficult for the human brain to fully understand nothing, and it's even tricky to say that before the Big Bang there was nothing. Since space and time were both created by the Big Bang, there wasn't really a before, and there was nowhere for nothing to exist. The Big Bang was neither big nor was it a bang. This name was made up to make fun of the theory that the universe was expanding. However, in 1927, Edwin Hubble discovered that what was thought to be a collection of dust floating around in space was actually other galaxies, and he was even able to calculate that these galaxies were moving away from us. Therefore, he understood that the universe was expanding, and if you go backwards in time, it means the universe all would pull back in to a central point where it all started, and this is the theory of the Big Bang. 2. Gravity matters. It produced our solar system. In 1687, Sir Isaac Newton published his law of gravity. This scientific law was kick-started, or so the story goes, when Isaac Newton saw an apple falling from a tree. The law of gravity says that two objects will pull on each other, and the strength of this pull will depend on their mass and their distance from each other. Gravity is what keeps your feet on the earth and stops you from floating off into space. Before our solar system formed, there was just this dusty cloud of simple atoms such as hydrogen, helium, oxygen, copper and iron. All atoms have mass, which means they all have a pull of gravity. And over time, these atoms pull together and collapse down, starting the chemical reaction involved in nuclear fusion, which powers our sun, and thus our star was born. This pull of gravity carried on throughout the rest of the cloud, pulling into clumps forming protoplanets, which later formed the planets, moons and asteroids that we know in our solar system today. Gravity doesn't just hold your feet to the earth. Gravity is also what holds the moon in orbit around the earth, holds the planets of our solar system in orbit around our sun, and what holds our solar system in orbit around the supermassive black hole at the centre of our galaxy. 3. Even though we can't see black holes, we know they are there. For a long time, black holes were just theoretical objects, until Jocelyn Bell Burnell discovered neutron stars. These are stars made up of neutrons which are all pushing against each other. However, over time, the gravity of this star overcomes that pushing force of the neutrons, and it collapses down into a black hole, from which nothing in the universe, not even light, can escape. Even though we can't see black holes, we know they are there because we can see the effects of them. Just like we can't see the wind, but we can see the effects of the wind. Albert Einstein said that mass would warp space. Imagine you've got a sheet of paper and you're holding it on either end and somebody puts a ball in the middle. You'd notice that the ball is going to warp the piece of paper and create a dip in it. Then, if somebody tried to roll a ball from one side of the piece of paper to the other, it won't go in a straight line, it will follow a bent path because of that first ball which is creating the dip in the paper. This is what we notice with black holes. Objects passing close to a black hole will get bent because of the way the black hole is warping space, and this includes light getting bent around the area where the black hole is. Anything which passes too close to the black hole will get pulled in by its force of gravity and will not be able to escape. 4. We don't know what 85% of the matter in space is made of. Everything we can see, including in our universe, such as stars, dust and planets, is made up of ordinary matter interacting with light, either by producing it, reflecting it or absorbing it. But this only accounts for 15% of the matter of things that we can see. The other 85% of matter does not interact with light, therefore we can't see it, and it is called dark matter. Although dark matter does not interact with light, it does interact with gravity. In the 1970s, Vera Rubin decided to research the orbiting speeds of stars around the centre of their galaxy. Now, it was thought that the further out a star was from the centre of the galaxy, the slower it would move. Just like in our solar system, the planets further away from the Sun orbit slower than the planets closer to the Sun. That is because there is 90% less gravity pull on the planets furthest out than there are the planets closest in. However, what was actually discovered was that the stars were all moving around in their orbit at roughly the same speed, no matter how far out from the centre of their galaxy they were. This meant that there must be some matter that was involved in this process that could not be seen. By subtracting the amount of matter that we can actually see, you can then work out how much dark matter is there. And that's how it's been calculated that around 85% of the matter in our universe is actually dark matter. 5. The furthest a human has travelled from Earth is 248,655 miles. This was achieved by the Apollo 13 astronauts on their mission to the Moon. Due to an emergency, they were unable to actually land on the Moon and instead had to pass round the back of it in a slingshot manoeuvre to fire back towards Earth. This was also at the point when the Moon was at its furthest distance from Earth. Although this is the furthest that humans have travelled, we have sent robots to other parts of our solar system, such as all of the rovers that we have sent onto Mars to roam about and explore, looking to see if there was any evidence of current or past life on this planet. The fastest that any humans have ever travelled in space was achieved by the Apollo 10 astronauts over 50 years ago on their mission to the Moon, when they travelled at around 24,800 miles per hour, and it took them 5 days to get to the Moon. In contrast to this, travelling at 165,000 miles per hour, that's almost 6.5 times faster than Apollo 10, it took the Juno probe 5 years to reach Jupiter. That would be 30 years for humans to travel that distance at our fastest speed that we have yet achieved. In the 1980s, 2 probes, the Voyager 1 and Voyager 2, were sent on a journey through our solar system. Both of these probes have since passed through our solar system and are carrying on their journey out into the universe. But as for human space travel, we are still going to need to wait a wee while longer before we will achieve any further distances than our Moon. 6. More than 4,000 exoplanets have been discovered and confirmed, while there are still thousands more that require further observation before they can be confirmed. So, what is an exoplanet and how do we discover them? Well, an exoplanet quite simply is any planet which is not within our solar system. The first person to come up with the idea of exoplanets was an Italian called Giordano Bruno, who came up with this idea in 1600. However, the church did not like his beliefs, so he was burned alive at the stake. Almost 400 years later, in 1988, the first exoplanet was discovered by humans. There are 3 main ways that humans use to discover exoplanets. One of these is direct imaging. Planets do not produce their own light, but they reflect the light of the star that they orbit. By looking at a star and taking pictures of what is around it over a long period of time, researchers are able to discover if there is a planet there reflecting light from the star, or whether it is just bits of dust that are floating about catching the light of the star instead. Another method is called radial velocity. Now, I'd said earlier that anything with mass will have a pull of gravity, and this includes planets having a slight pull of gravity on the star that they orbit. By observing a star, scientists are able to see a wobble in the star where the planet is pulling on the light, and the star ends up getting a bit distorted through the observation. From this, researchers are able to tell if there is a planet orbiting the star after observing it over a long period of time. The third key method is called the transit method. Now, for this one, what researchers do is they observe a star and they will actually see a black spot moving across the front of the star as a planet orbits around it. Unfortunately, you need to be in the perfect position looking straight at the star on the path of that planet's orbit to be able to see it move across the light of the star. However, this is actually the most successful way that researchers have used for discovering exoplanets. With all of these methods, it's easier to find a large Jupiter-type planet than it is to find an Earth-type planet. 7. When you look at stars, you are looking into the past. We know that stars are bright. After all, the sun is what lights up the Earth, and moonlight is just reflected light from the sun. So why is the sky dark at night, despite being filled with all of these bright stars? The universe is not infinitely old, it did have a beginning, with the strongest theory for how the universe began being the Big Bang theory that I mentioned earlier. Light has a set speed of 186,000 miles per second, so we can only see light which has had time to reach us. If you are looking at a star that is 4 million light years away, you are seeing the light that left that star 4 million years ago. So you're looking into the past. The universe is constantly expanding, which means there is more space for the light to spread out in. But it also means that the light that we can see is actually moving away from us. As light moves away from you, it moves into the red part of the colour spectrum. And there is some light that has moved so far away from us, it's moved into infrared or microwaves, which we cannot see with our eyes, but we do have some high-powered telescopes which can detect infrared and microwaves. With the distances involved in space, the expanding universe hiding light, the time it takes light to travel, and the fact that the universe is not infinite, so there's not an infinite number of stars, that is why the sky is dark at night rather than being lit up by all of the stars that are there. 8. Aliens probably exist somewhere in the universe. When the question of intelligent life in the universe comes up, there is a lot that we need to consider. The Earth formed around 4.5 billion years ago, and it took the simplest life forms, bacteria, around 500 million years to form. It took the full 4.5 billion years for intelligent life to appear on Earth. I did a video previously where I looked at a full timeline of the history of the Earth, so I'll put a link in the description for you to check that out. Our Sun is of a size where it's not too hot and it's not too cold. It formed around 5 billion years ago, and it's estimated it has about another 5 billion years before it burns through its fuel source. Larger stars burn through their fuel source much faster, and smaller stars are much colder. So, like Goldilocks and the Three Bears, our Sun is just right. Also like Goldilocks and the Three Bears, our Earth sits in what's called the Goldilocks zone, which is the area in our solar system where we are not too close to the Sun to be far too hot for life, and not too far away to be too cold for life. We are in just the right position. Similarly, our solar system is in just the right part of our galaxy. If we were much closer into the centre of our galaxy, our solar system would get bombarded with radiation from the centre of the galaxy, and this would make it really difficult for life to start. Our planet also formed in an area of space where there was carbon, oxygen and nitrogen, all of which are essential for the formation of life. Now, when you take all of this into consideration, all the number of stars and planets that there could be in the universe, it's estimated that there are around 100,000 possible areas where intelligent life could exist in the universe. 9. What came first, the galaxies or the supermassive black hole at their centre? It's not yet understood how supermassive black holes form. Ordinary black holes form when the core of a massive star collapses inwards after it's used up all of its fuel, and then explodes in a supernova, leaving a black hole behind. Now, it takes black holes a certain length of time to be able to expand, so theory suggests that not enough time has passed from the start of the universe for stars to have been able to form, explode into a supernova, become a black hole, and then expand to the size of supermassive black holes. These supermassive black holes must have formed some other way. The best current theory on the formation of supermassive black holes says that when the universe was formed and you had all the particles of dust floating around, that the mass, gravity and density of collections of this dust all collapsed inwards, and this is what formed as supermassive black holes. One of the aims of the James Webb Space Telescope, launched in December 2021, is to use infrared imaging to look at more distant objects, and maybe then we will get more ideas about what came first, the galaxy or the supermassive black hole. 10. There is more we don't know about space than we do know. This means we can look forward to the new discoveries and knowledge that we will gain with continued exploration of our universe. And this is not only done by researchers. There are lots of citizen science projects such as Galaxy Zoo, where members of the public can help researchers with data-heavy tasks, such as looking at images to classify galaxies. Researching space has also changed our lives here on Earth by being able to take advantage of new technology developed for the space industry, such as medical imaging scanners, which use technology developed by astronomers to help them see further in the universe, digital detectors, which are in your mobile phones and were designed to take the place of photographic plates, And your mobile phone also takes advantage of Wi-Fi, the technology of which was advanced to help radio astronomers. There are two things you should keep in mind at the end of this video. One is that we are all naturally curious as children, but we tend to lose this curiosity when we become adults. We should all take time to look up at the sky at night and marvel at the things that we have discovered about the universe, and also wonder about the things that we do not know that will be discovered in the future and may even be discovered by you. The second thing is that the atoms required for life to make you came from stars which have died. The atoms that make up your left hand could have come from a completely different star than the atoms that make up your right hand. And this is something that unites us all as a species. We are all made of stardust. Thank you for watching this Things You Should Know video. The majority of the information for this video came from 10 Things You Should Know About Space by Dr. Becky Smethurst, as well as A Universe from Nothing by Professor Krauss, and other space books which I have read. There are lots of great space books for children, as well as great novels which use space as a theme, such as George's Secret Key to the Universe by Lucy and Stephen Hawking, and The Jamie Drake Equation by Christopher Edge. If you liked this video, please hit the like and subscribe button to stay up to date on all future content. You can subscribe to the channel by pushing the button here, and I've added a link here to my other Things You Should Know videos, and then down at the bottom a link to my STEM demonstration and explanations and to my STEM career interviews. This has been STEM with Mr. N with 10 Things You Should Know About Space.